So this video is going to be quickly going over how to calculate serial dilutions. For the purposes of the test, I won't be asking you too many complicated questions. This is just good for you to know if you are taking a chemistry course in college, because it's really essential to be able to do serial dilutions in order to calculate different kinds of things in chemistry. So again, you can start with anything here. So this could be any value. It usually depends on what kind of concentration you buy. So stock solution is something you get from a store. So the store has a stock, and that's why it's called a stock solution. It's basically something that you're given, and that may not be the concentration that you'd want to use in your experiment. So you start with any concentration of a so-called stock solution. And let's assume you have a lot of this concentration. You're not restricted, so we'll just pretend you have 100 milliliters, which is not really a lot, but just you have a sufficient quantity. And now it depends on what you are trying to dilute by that really affects your calculations. So two things you have to decide. You basically decide your dilution factor, and you decide how much volume of something you need. So what you basically always have to calculate the V1. So how much volume of the previous solution you need to make the new solution. So if I'm making solution 1, I have to decide how much volume of stock I need to make my new solution. And this can be fairly intuitive, but we'll go over the calculations once just in case. These two variables you get to pick. So the C2 depends on dilution factor. So if I'm diluting it, so for example, we'll just do the same example that we did in class. So let's say I want to dilute it by 10. So I want a 1 molar solution because I'm dividing this by 10. So I want, instead of a 10 molar, I want a 1 molar solution. And the next one, I want a 0.1 molar solution. And then let's just say, for the sake of argument, I'm going to switch it up. And instead of a 0.01, I want a 0.05 molar solution. So this was down by 10. This was down by another 10, but this is only going down by a factor of 2. So I've only halved it, and we'll see how that calculation is essentially going to change. And the volume, this depends on how much I need. So again, you can decide this, and I've usually given you, I need 50 milliliters. So I want, let's say, if I want 50 milliliters just to be safe, let's say I want 100 milliliters of each solution after I have completed my dilution, just because I will be using these solutions for other things in my experiment, so I just want to make a bit of extra. But you can decide this. If you say I want exactly 50 milliliters, then you can go with 50 milliliters. You can decide these two values for yourselves. And so concentration 1 is the stock concentration, so that's already given to us, would be 10. We have to calculate volume 1. Now our C2 depends on our dilution factor. I want a dilution of 10, so our C2 will be 1. And V2, I said I wanted 100 milliliters, so I'm just going to put 100 into here. And you can see that I have to divide both sides by 10 to solve for V1. And this V1 becomes 10 milliliters. So what this means is this 10 milliliters is what goes into my volume of solution. So I need 10 milliliters of stock, right? But you'll notice that my volume that I needed was 100 milliliters, right, in total to get this, my second concentration. So in order to get this, I have only 10 milliliters, so I have to get to 100 meters using something else. And that something else is, of course, water, which is our solvent of choice. So I need to add 90 milliliters of water just to get my total volume up to 100 milliliters, right? Now again, you can repeat this calculation, but since I'm doing a dilution of 10, this will end, I'm keeping the same, so let's assume I still want 100 milliliters. This calculation will be essentially the same. I'll take 10 milliliters of my previous solution, solution number 1, which was the one that I made here, and to it I'm going to add 90 milliliters of water, and I will get a basically a dilution factor of 10 again, because I'm doing 10 milliliters of this solution and 100 milliliters of like total solution after I've diluted it with water. So the water is basically what is doing our dilution here, and that's important to note, right? So now let's see how our calculations will change when we have the 2, dilution by 2. So we're still using C1V1 equals C2V2, and I told you these two are things that I can change. So C2 becomes, I want to dilute it by 2, so instead of 0. I basically do 0.1 divided by 2 and I get 0.05, right? So that's how I came up with that number right there, because I wanted a twofold, or dilution by half. I took my previous concentration, divided it by 2, and got a dilution. Got a concentration. My volume, again, I can decide, instead of 100 milliliters, let's say I'm going to use 50 milliliters, for example, just to change it up. Again, I can decide what these two are. This one, maybe I'll give you in the question, I want a dilution factor of half, or you will usually know what kind of dilution factor to use, but the volume just entirely depends on what kind of experiment you're doing and how much water you need. So the C1 here is our previous solution, so 0.1, and we have to find the volume of that solution that we need. So again, I'm going to divide both sides by 0.1, and I'm going to do this in my calculator, which gives me 25 milliliters. So here for 3, I need 25 milliliters of solution 2, but remember I need a total volume, I decided, of 50 milliliters, so I have to add another 25 milliliters of water to get my total volume up to 50. And this, intuitively, if you think about it, makes sense. I want to dilute it by half, so I take 25 milliliters of that and add 25 milliliters of water. So that's basically effectively halving, it's making the concentration half, is basically what it's doing. And you can decide any dilution factor you want. You can decide your V2 depending on your experiment, and you can calculate your V1, but that's essentially what a serial dilution is. So hopefully this was good, and I will see everybody in class.